Imagine you're standing in front of like a giant pile of bricks,
Right.
steel beams, maybe a few pallets of glass,
Okay, I'm picturing it.
and you've been tasked with building a 70-story skyscraper. But instead of hiring structural engineers or, pouring a concrete foundation or setting up a power grid,
You just,
you just walk right up to that pile of bricks and start whispering magic words to it.
right, just hoping for the best.
Yeah, you just stand there tweaking your phrasing, hoping that if you just give the bricks the absolute perfect instructions, they'll just spontaneously assemble themselves into a functional high-rise.
Which is, I mean, it sounds completely absurd.
Exactly. It sounds like a joke.
Yeah.
But that is exactly how most of the corporate world is currently treating artificial intelligence.
Yeah, it really is a phenomenal illusion. I mean, we have spent the last couple of years essentially teaching people how to whisper to the bricks.
Right.
And we've completely ignored the engineering required to, actually build the building.
So today, for this deep dive, we are stripping away the fluff to rip apart this whole illusion of prompt engineering. Our roadmap for this conversation comes from two incredibly sharp insider sources.
Yeah, really good stuff.
The first is this operational document titled Anthropic has a free academy and almost nobody talks about it. And we're combining that with the deployment philosophy of Borion AI.
Right, a group that is just deeply, deeply focused on operationalizing these systems.
Exactly. So, okay, let's unpack this. Why is the corporate world still so completely obsessed with finding the perfect prompt, like the ultimate magic phrase, when the actual pioneers in tech have already abandoned that approach?
Well, because prompting was a highly visible, very necessary first step,
Yeah.
right? When large language models first hit the mainstream, the immediate barrier to entry was simply getting the model to produce a useful output.
Right, just getting it to talk back in a way that made sense.
Exactly. So an entire cottage industry just sprang up around this idea of prompt engineering.
Yeah, you saw it everywhere.
I mean, it gave non-technical people a way to interact with incredibly complex technology. But the reality is, prompting is utterly insufficient for real enterprise outcomes.
Wait, let me push back on that for a second.
Sure.
From a business perspective, isn't getting the model to say the right thing, to give you the correct answer, isn't that the hardest part of all this?
Not at all.
I mean, if the model is smart enough to generate the right output, hasn't it done its job?
See, generating the output is actually the easy part. What's fascinating here is that the real engineering challenge is state maintenance. It's resilience.
State maintenance.
Yeah, like, can that system maintain its context across a complex multi-step workflow that takes hours to complete?
Oh, I see.
Can it seamlessly connect to real, messy, unstructured data sources in your production environment? And crucially, and this is where most break down, what happens 6 months from now when the underlying data distribution shifts?
Right, when the real world changes.
Exactly. If your entire system is just a fragile chain of prompts, it will break. The second reality doesn't perfectly match your test environment.
The magic words stop working.
Right. You need systems that log every single autonomous decision for audit purposes, Systems that know how to gracefully escalate to a human when they hit their limits. Prompting cannot do that. Only architecture can.
So because so many teams are, entirely focused on the prompting instead of the architecture, they inevitably fall headfirst into a very specific, and I'm guessing very expensive trap.
Oh, massively expensive.
If you're building AI right now, you have probably seen this exact life cycle. A team builds a proof of concept, everyone gathers around a laptop, the team enters a prompt, and the demo performs brilliantly.
Flawlessly, usually.
Right. The executives are thrilled, the business case is made, the funding gets approved.
And then
but
the project completely stalls.
It just dies somewhere in the void between that impressive demo and actual production.
Yeah, we call that the demo trap.
The demo trap.
And it happens because the team fundamentally misdiagnosed the assignment. They thought their job was to prove the model was smart.
Which it is.
Right, but the model's intelligence was never the problem. The problem is a total lack of engineering discipline. The team knows exactly how to prompt the model under perfectly controlled conditions.
Because it's on a laptop.
Exactly. But they have absolutely no idea how to build a resilient system that holds together at scale.
It really makes me think of, a Hollywood movie set.
Oh, no, that's a good analogy.
You watch a movie and you see this beautiful, fully functioning house. It looks amazing on camera. But if you were to actually walk onto the lot and open the front door of that house, you'd realize there's no plumbing.
None.
There's no electricity. It's just a wooden facade held up by some scaffolding. That is what an AI demo is. It's a facade. but the executives funding it think they just bought a real house.
And when you try to move that facade into the real world, the scaffolding collapses. Because a demo is an isolated event, production is continuous survival. Let's take an API rate limit, for example.
Okay.
In a demo, you ask the model one question. In production, 1,000 users might hit the system at the exact same millisecond.
Oh, wow.
The server on the other end is going to panic and send back an error code saying, slow down, you've exceeded your rate limit.
And a prompt can't handle that.
A prompt doesn't know what to do with an error code, it just crashes.
It just dies.
Yeah. But a properly architected system intercepts that error, pauses for a calculated few milliseconds, and automatically retries the request without the user ever even noticing.
Because the plumbing is there.
Exactly. Survival requires logging, error handling, rate limiting, security boundaries. If you don't have the engineering discipline to build that infrastructure, your AI initiative will never, ever leave the staging environment.
Okay, so if the entire industry is stuck in this demo track, how do you actually build that missing engineering discipline? Like, where do you go to learn how to build the plumbing?
Well, that's the big question.
Here's where it gets really interesting. The answer is hiding in plain sight. It is the ultimate insider resource, and almost nobody is talking about it.
It's wild how under the radar it is.
The platform is anthropic.skilljar.com, and the scope of what is sitting there, entirely for free, requiring nothing more than an email address, is just staggering.
It really is.
We are talking about 18 distinct courses, structured learning paths, quizzes, and official Anthropic certificates.
What makes this catalog so vital is that it completely rejects that whole prompt hacking narrative.
Right.
It treats AI deployment as a serious software engineering discipline.
Just to give you a sense of the breadth here, it starts with things like Claude 101, which is great for onboarding.
The base.
Then there is AI Fluency, which actually has specific companion versions tailored for educators, nonprofits, and small businesses. Then you get into Claude Code 101, which is about integrating the model into your actual development workflow, not just, chatting with it.
Moving past the chat box.
Exactly. They even have cloud platform courses covering Amazon Bedrock and Google Cloud's Vertex AI for, deep enterprise infrastructure.
The depth of these courses directly reflects the actual unvarnished complexity of enterprise AI. I mean, it is a rigorous curriculum designed for serious technical practitioners who realize that the game has fundamentally changed.
Okay, so if we're tearing down the Hollywood facade, what are the actual load-bearing walls here? What separates a demo builder from a true systems architect?
Well, there are specific primitives you have to master.
All right, let's dive deep into the specific engineering primitives taught in this academy.
Hmm.
Because there are 3 core architectural tracks here that represent the absolute bleeding edge.
Yeah, these are the big ones.
Let's start with the first one, which is covered in this massive 8+ hour course called Building with the Claude API. And this is all about system prompt architecture and context window management. Walk me through that, because I gotta say, system prompt sounds suspiciously like the prompt engineering we were literally just mocking.
I know, the naming can be confusing, but it is entirely different. A basic prompt is an instruction for a single task. A system prompt architecture is about defining strict, unbreakable operational constraints.
Oh.
It's about defining behavioral boundaries that survive messy, adversarial, real-world data. When you build an enterprise system, you aren't just asking the model a question, you're dropping it into a highly unpredictable environment.
So it needs rules.
Exactly.
Yeah.
The architecture dictates how the model handles a user who tries to trick it, or, how it responds when a database returns a completely corrupted file.
So it's basically the rules of engagement.
Precisely.
But how does that play into the second half of that course? Context window management. If the model's context window is basically its short-term memory-like, a strict limit on how many words it can process at one time, how does a system prompt help manage that?
Okay, so a demo builder just copy-pastes a bunch of text into the chat and hits send, right?
Yeah, I've done that. We've all done that.
We all have. But a systems architect builds an automated triage system. They implement code that dynamically decides exactly what information the model needs at any given millisecond.
Okay, give me an example.
Let's say you have an internal support bot, and a user asks a question that requires reading a dense 500-page technical manual.
Right.
You can't just shove all 500 pages into the context window for every single question.
It would max out.
It's too slow, it's too expensive, and it completely overwhelms the model's memory.
Right. The model would probably lose track of the actual user question by the time it's finished reading, like Chapter 2.
Exactly. It suffers from what we call lost in the middle syndrome.
So what does the triage system actually do to fix that?
Instead of dropping the data entirely or trying to summarize it on the fly, you compress it into vector embeddings.
Vector embeddings.
Yeah, think of a vector embedding like taking that dense 500-page report and boiling every single paragraph down into a complex mathematical barcode.
A mathematical barcode. I love that analogy.
Right. So when the user asks a question, the architecture translates their question into a barcode, scans the database for matching barcodes, and extracts only the 3 specific paragraphs that are mathematically relevant to that exact question.
Oh, wow. So it's
Well,
hyper-targeted.
the model never even sees the other 499 pages. It only receives exactly what it needs to answer the question, keeping its cognitive load incredibly light and focused. That is pure engineering.
Okay, so once you've used system prompts to give the model boundaries, and you're managing its memory dynamically with these barcodes, it's secure and efficient, but it's still trapped inside a box, right?
It is.
How do you actually let it reach out and touch your company's live data without breaking those boundaries? That brings us to the second piece. The Academy has an entire course dedicated to the Model Context Protocol, or MCP.
Yeah, MCP. This is huge.
I really need a clear explanation of this because it sounds incredibly abstract. What actually is MCP?
The Model Context Protocol represents the exact moment we completely abandon the chat window. MCP is an open standard that allows models to securely connect to external tools, production services, and live databases.
How so?
Imagine you hire a world-class Michelin star chef, but you lock them in a dark room and you only slide recipes under the door.
That sounds terrible for the chef.
Right. The chef knows exactly how to cook, but they have no pots, no pans, and no ingredients. A traditional chat interface is that dark room.
So MCP is turning on the lights and labeling all the kitchen doors.
Exactly. MCP is a standardized protocol, a universal handshake. It gives the chef a standardized set of kitchen utensils. Instead of a human typing a request, getting an answer, and then the human going to a database to execute it.
Which is how we use it now.
Right. MCP allows the system to do the heavy lifting itself. It provides a secure, predictable way for the model to reach out, query the live database, read the result, realize it needs more information, trigger an external API, parse that response, and then execute a final action.
All on its own.
All on its own.
Let's ground that in like a software scenario. Let's say an engineer types a message to their internal tool saying, "Why did our login server crash last night?"
Okay, without MCP, the model just says, I don't know, I don't have access to your servers.
Right, at an AI language model.
Exactly, the classic CAN response. But with MCP, the model translates that human question into a specific database query, reaches through the MCP connection, pulls the server logs from last night, reads the error codes, identifies the crash, and then formats a detailed report.
Without the engineer doing anything else.
It does all of this autonomously in a highly controlled, secure way. It is the connective tissue that takes an isolated AI model and hardwires it directly into your company's existing production infrastructure.
Okay, so the model has tools, it has boundaries, it can touch the live database. But what if the job is just too big or too complex for one single model to handle from start to finish?
That is the big question.
And that brings us to the third core track, which involves courses like Introduction to Subagents and Introduction to Agent Skills.
Yeah, this is the 2025 reality.
Multi-agent systems.
We are moving rapidly away from single model interactions and entirely into multi-agent architectures, relying on one massive generalized AI model to do absolutely everything in your company is slow, it's incredibly expensive, and frankly, it's highly prone to errors.
Because it's trying to be a jack of all trades.
Exactly. Instead, you build a network of specialized sub-agents.
So if I have 3 different agents doing 3 different tasks, who is playing traffic cop? How do they not just overwrite each other's work or get stuck in some endless loop?
You build automated task delegation frameworks. You create a hierarchy.
Like an org chart for AI.
Precisely. You might have a supervisor agent whose only job is holding the master plan and delegating tasks. The supervisor doesn't actually do any of the coding or database querying.
Oh, interesting.
It just hands off those tasks to specialized sub-agents. So going back to our server crash example.
Right, the login server.
The supervisor gets the user request. It pings Agent A, whose only skill, its only job, is querying the log database. Agent A gets the logs and hands them back to the supervisor.
Okay.
The supervisor then pings Agent B, whose only skill is analyzing Python stack traces to find the bug. Once Agent B finds the bug, the supervisor pings Agent C to automatically draft and open a Jira ticket for the engineering team.
That is wild. But wait, what happens if Agent B fails? What if the logs are corrupted and it literally can't find the bug?
Well, that's the beauty of the architecture. If Agent B fails, it doesn't crash the entire system.
Well, like a prompt would.
Right. It passes an error state back to the supervisor. The supervisor reads the error, realizes the logs were corrupted, and pings Agent A again, saying, hey, try pulling the logs from the backup server instead.
Oh, wow. It self-corrects.
You create libraries of reusable skills that any agent can call upon when needed. You build systems to resolve conflicts when two agents disagree. That is not prompt engineering. That is deep structural software architecture.
So what does this all mean? I want you, the listener, to really visualize this shift. We are talking about moving from treating an AI like a magic text box that you ask questions to treating it like a core microservice hardwired directly into your company's central nervous system.
Yes.
It's not just a tool you use, it's an infrastructure you deploy. And these courses on anthropic.skilljar.com spell forth the API tracks, the MCP protocols, the subagent frameworks. They aren't just like theoretical homework assignments.
Not at all.
They are the exact blueprints being used by elite deployment teams out in the wild right now.
And this is where the operational philosophy of Borion AI becomes so incredibly relevant.
Right, Borion.
Borion's stance is incredibly clear on this.
Yeah.
The architecture patterns covered in Anthropic's curriculum are not academic exercises. They are not sandbox toys. They are the exact required infrastructure primitives used to deploy stable, resilient systems for large enterprises.
There are no shortcuts.
If we connect this to the bigger picture, Borion AI makes it clear that if an organization actually wants to move from just running AI experiments to delivering real operational AI systems, this architectural foundation is the only path forward. You simply cannot skip the plumbing.
It's the ultimate reality check for corporate leadership. The gap between a clever demo and a secure multi-agent production system is entirely an engineering gap.
100%.
And the market is about to severely punish companies that do not understand the difference. We are exiting the era of novelty, right? We are entering the era of execution.
Right.
If you aren't architecting, you're just playing in the sandbox.
Yeah.
You are building those Hollywood facades while your competitors are building actual skyscrapers.
The companies that survive this next wave will be the ones whose engineering teams treat AI as a distributed systems problem rather than some linguistic parlor trick.
So bringing this all back to you, the listener, why does this matter for your team or your career or your company's roadmap?
Well, the barrier to entry is gone.
Exactly. Because if you are building with AI right now, the barrier to acquiring this deep structural knowledge has literally been removed. The SkillJar platform is free. The investment required to learn how to build multi-agent systems and deploy MCP is just time. It's not money.
The tools are literally sitting right there on the table.
Right. So the real question isn't whether this architecture knowledge matters. I think we've established it is basically the only thing that matters. The actual question is whether you are going to build this capability before or after the competitors in your industry do.
That raises a really important point, and it's something I want to leave you to mull over.
Okay, let's hear it.
We are rapidly approaching a point where foundational models will eventually plateau in their raw, generalized intelligence.
Right, they can only get so smart.
When that happens, everyone will have access to the exact same baseline models. The actual brain of a company, the thing that gives them an edge, won't be the model itself.
It'll be the system.
The true brain of the enterprise will be the intricate multi-agent nervous system that you have architected around that model. So ask yourself, if your entire competitive advantage right now relies on a single, clever prompt typed into a chat box,
Right.
what happens the day a competitor deploys an autonomous swarm of subagents that completely bypasses the chat window entirely?